Okay, so hey again everybody. I just wanted to make another video showing a bit more of the controller functionality than the last video you saw. So I'm going to walk through basically how to start up the controller, how to give it certain tasks, how to play with those tasks, and maybe show you some compliancy afterwards. So to start with, we need to make sure we start up all the appropriate modules in order to launch the controller. So you need to have whole body dynamics tree running along with a joint torque control for all of the robot parts you'll be using. Once you have all that set up, launching the controller is as easy as typing in the name of the binary, ISIR-WholeBodyController, and then clicking enter. Now what this will do, if you launch it with no arguments, will basically set up the baseline tasks necessary to maintain posture or not fall over. What's a little bit more cool is that we can pass in a set of tasks via XML, just an XML file. And so what does that look like? Well, basically we have something along the lines of what you see here, where we can specify the name of the task and its type along with all of its various parameters. Now the different types of tasks so far are relatively limited. Right now we only have posture, Cartesian, pose, orientation tasks. We're adding force and contact. But for now you can specify all of this, and in the fixed, we've tested pretty much everything in the fixed base case so far. So as you can see, you can load in with a couple of different syntax styles depending on what you like, and you can set in the desired values, frame offsets, stiffness, damping, weight, etc. So I won't go into all the details of how to specify a task, but you can do it in XML, which is pretty neat, so you don't have to recompile every time. So once we've got our set of tasks that we want to load, all we have to do is pass it in as an argument to our controller. So we'll give it the flag at task set, and then we'll find our path to the task set. So we can use an absolute path or something along those lines. I'm not going to type it all out, but here's the task set we'll be using. It's simply the path to the one I showed you right here. So once we have the task set ready to go, all we have to do is click enter, and the controller will automatically start up. Now if you're watching the robot, it should move into some basic position here where the two hands are trying to maintain two positions in the Cartesian space, and there's the two posture tasks trying to keep the robot relatively upright. So the controller is now started, and as you can see on the terminal, it's opened up a port for each one of the tasks that we had in the XML file, along with a port for the controller itself. So what can we do with these ports? So if we open up a new terminal here, and we RPC into those ports, so let's RPC into the Cartesian right-hand task, we have access to all of the task variables essentially. So if we type help, we'll get a printout of basically all of the arguments we can give. Now with this high font size, it's sort of hard to see everything, but basically we can set a bunch of different values. So one of the cool things we can do is actually activate and deactivate tasks. So if I type in deactivate, you'll see the right-hand task has now been set to a priority of 0 and is essentially removed from the controller. Now it's still there as a task, which is nice because when we activate it, it'll go back to its original position. Something else we can do, let's deactivate again. Now we can also set the KP, for instance, by saying set stiffness. Whoop, if I can spell correctly. And then let's set it to 50. So now the stiffness has been set to 50, and if we reactivate, you'll see that the movement we get is a little less aggressive. Now the movement you saw in the first one was pretty aggressive because basically the desired value we were giving to the hand task was generating a really big error, and we're multiplying that by a pretty large KP, and so that's why you get that sort of aggressive movement. Now since we've changed the KP, we get a less aggressive movement, but as you can see, it doesn't quite get to the same place as the last task. So if we want to, while the task is activated, we can again set the stiffness a little higher, say 150, and you'll see the robot tries a little harder to get to that original position, which is nice. Okay, so that's cool. Let's close out of the right-hand task. Now if we go to left-hand task, we can do all of the same things. And one of the cool things we can do is actually set the desired value of the task. So right now the left-hand task, we want to see what the current desired value is. So we say get desired. Okay, so that was what I put in the XML, and basically the format here is XYZ, and then velocity, and then acceleration. Because it's a Cartesian task, we're only controlling the XYZ coordinates. Alright, so now I want to change this, so all I have to do is type in set desired, and then the appropriate state that I want to give it. So let's say we want to stay at the same X position. Maybe we want to come a little bit inward, so we'll give it a smaller y. Maybe we don't want it to collide. And then let's give it a positive z value. Let's make it come up. And then basically we just have to put in zeros because we don't want any velocity or acceleration at the end of the movement. So make sure I got all the right numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're good. So if I type in set desired, the new desired location for the hand task is changed. So if I do get desired, it will respond basically telling me, confirming what I already know. So that's pretty cool, because basically what this means is that these tasks you activate, and then their desired locations can be set by, for instance, a trajectory tracking layer, which can be placed on top of this, and we're currently working on that. Because as you can see, jumping from one position to another with essentially a feed-forward PD controller isn't exactly the smoothest of movements. Okay, so the final thing I want to show is basically the controller RPC port, which allows us to manage the tasks, basically adding and removing tasks. So if we open ourselves up an RPC into the ISIR controller port, again, we can type help and get the various arguments, but for right now, we're just going to remove task. Well, we don't know, maybe we don't remember all the tasks that are on there, so let's get the task list. And that'll tell us all the tasks we have on. And now we want to remove task, cart, left hand. Okay? As you'll see, the left hand task is now permanently removed from the controller and its ports are gone. Okay, so we won't be able to set any more values on that task. What we can do, though, however, is add tasks. So we can add tasks via YARP or via XML. So let's look at a different XML file, which is simply a left-hand task. And we want to add this to the controller, so we're going to give it, change its weights a little bit. Let's make this 70. Okay, great. So now that that task is ready to go, all we have to do is basically say add task, and then we need to specify that's an XML task, and then specify the path to it. So home, task XML. Okay, once we click enter, you can see that the new cart left-hand new task is now active, and will have all of the same functionality as any other task. So that's the basics of the controller. I'm just going to go around real quick, and I just so everybody believes it, it is still a compliant controller. And as you can see, because we're holding a Cartesian task, when I move it, it will try to correct, which is kind of nice. The gains aren't so high, so it doesn't correct too aggressively. And pretty decent compliance. Again, we still have some gain tuning to do, but so far that's basically what you can do, and we think there's quite a bit of flexibility in the controller. Now one final thing I'll show is, let's close down the controller. So just Control C and it'll basically send it back to a home position. It's going to close all of the various ports. Okay, everything's finished. Now, just for the sake of safety, I'm going to recalibrate whole body dynamics tree. And I now am going to put the robot into its typical home position. Okay. And finally, we're going to show you one last thing. You can actually launch sequences of tasks, which are basically tasks with a little bit of control logic. And the way you go about doing that is by typing in ISIR-WholeBodyController, and then sequence, and then the name of the sequence. So we're going to do trajectory tracking. Test. Okay, when we launch that, you'll see the robot's going to track a trajectory with its left hand and go to a simple Cartesian position with the right hand. And I just want to show you this to illustrate a little bit better the task-based things we can do with the controller. And finally, let's see, I'm just going to show you one more thing, because I think it's relatively cool. So if I push the arm a little bit, if I perturb that, you'll see it's actually trying to correct to hold its position, which is kind of nice. Again, it's exploiting the redundancy of the movement, which is kind of cool. Same for the other hand. That's cool. And it remains pretty compliant. A little jiggly though. Alright, that's it.